All right, so we're now continuing on to our same section of 3E, multi-step equations, and we're now going to be in our second part of this video. So in this video, we're going to focus on 3 and 4. So that's what we're going to try and make sure that you understand how to do by the end of this video. So by the end of this video, hopefully you will understand how to solve multi-step equations with variables on both sides of the equation, and also how to solve proportions. All right, so let's go ahead and get started by going over some examples and talking about how to solve each of these. All right, so let's say that we're given a problem, 5x minus 4 is equal to 2x plus 23. In every single question when we're solving, we need to write it that x is equal to some number. We're trying to solve for what value x is. So when we know that we're trying to get down to here, we only have one x. We can't say x is equal to some number plus x because then we're not actually solving for x because we have two of them at that point. So our goal when we're solving for our variable is to isolate it and get it down to just one variable that has a coefficient of 1. So when I look here, I see I have x's on both sides of my equation. So that means one of the first things that we want to do is move all of our like terms, all of our like variables to the same side of the equation because we eventually just need to get x or our variable is equal to a number. So when we're doing this, and I see I have variables on both sides, I'm going to move my variable to the other side of the equation. And the only way that we can move variables from one side to the other is through addition or subtraction. Because if I said, okay, I'm going to divide by 2 here, that's not clearing out this x to be equal to 0. That's actually clearing out x to be 1. And we'd still have that x on that side of the equation. So when we're trying to move them, we will add or subtract. So in this case, it's a positive 2x. So to move x to the other side of the equation, I need to subtract 2x. And what I do to one side, I need to do to the other so that way I keep it balanced. And 2x minus 2x is equal to 0. So that clears out my variable on that right-hand side. And now I have 5x minus 2x, which is 3x. So now 3x minus 4 is equal to 23. Now this looks like a regular multi-step equation that we were just solving in the last video. So I look and say, okay, well, what is being done to my variable? Well, 3 times x minus 4. So I'll write out my PEMDAS. I know I'm going to go in this direction. And I see, okay, I'm multiplying and I'm subtracting. So now before I even get started, I'm just going to say what these inverse operations are. So subtraction is addition and multiplication is division. So then from here, I'm just going to go ahead and solve. I need to get rid of my subtraction first. So that means I will add 4 to both sides. So then I get 3x is equal to 27. 27. And then I need to get rid of my multiplication through division. So I'll divide each side by 3. And x is then equal to 9. So make sure you're writing x is equal to 9. If you just say 9, you're not telling me what your variable is equal to. So make sure you're writing it x is equal to 9. All right, so now if you wanted to check your work, we can plug it back in. Does 5 times 9 minus 4, does that actually equal to 2 times 9 plus 23? Well, 5 times 9 is 45. 45 minus 4 is 41. 2 times 9 is 18. 18 plus 23 is 41. So yes, it does work. All right, so our goal when we have variables on both sides is to move all of our variables to one side, our like variables to one side, so that this way we can start to get a multi-step equation that we are used to, that we know how to solve, and that we can actually go forward with. So we can't leave our variables on both sides because we're not actually solving for it, because then that variable would be part of the answer, which we can't have. All right, so this is something that a lot of people will make mistakes, so is they will just add this 2 and this 5 and say 7x. So remember, when we're moving it to the other side of the equation, we need to do inverse operations. All right, now we have this problem that says 5 times w plus 1 is equal to negative 4w minus 40. So from here, the first thing that we need to do is what we did in the last video, is we need to simplify each side of the equation as much as we can first before we do anything. So when I say this 5 times, that means I'm going to distribute this 5 in. So this is 5w, let me make this a little bit thicker. 5w plus 5 is then equal to negative 4w minus 40. All right, so first simplify everything you can. And now, same thing, I see I have variables on both sides of my equation, so I'm going to move them to one side. You don't have to move it to the left side. You can move it to either side that you want. You'll always just see me, though, move my variables and keep them on the left-hand side. Once I think that we are strong in these, I can show you guys different ways of going about solving these questions. But in the beginning, I'm just going to show one way the entire time so that this way we can practice one specific way before trying to move on to multiple methods. All right, so to move a negative 4w, well, the inverse operation of minus 4w is adding 4w to both sides. All right, remember, that is minus 4w there. So 5w plus 4w is going to give me 9w. So now I have 9w plus 5 is equal to negative 40. Don't forget that this is minus 40. So now that I have all my variables on one side, I'm going to write out my PEMDAS. I know I'm going in reverse order. So let's see what is being done. Well, I have 9 times w, so I have multiplication. I have addition. So then from here, I'm going to say, well, the inverse of addition, subtraction, the inverse of multiplication is division. So to get rid of our addition first, I'll subtract 5 from both sides. So 9w is equal to negative 45. And then I'll divide each side by 9. And w is equal to negative 5. And that will be our final answer. Same thing, you can plug it back in to check, does it work? So 5 times negative 5 plus 1. Does this equal to negative 4 times negative 5 minus 40? Well, negative 5 plus 1 is negative 4, times 5 is negative 20. And negative 4 times negative 5 is positive 20, and positive 20 minus 40 is also negative 20, so yes, it does work. All right, so now we're going to go ahead and move on to solving proportions, and there's 1 or 2 questions we'll do with that. All right, so now we're going to start off with a really easy problem for this one first. So we have x over 4 is equal to 15 over 20. There are multiple ways you can go about solving this particular question. I'm only going to show you one because when we get into a little bit harder questions, which we're going to do next, it's not as easy to do some of these other methods. So I'm only going to show you one way, and this one way works every single time. All right, so let's say before we get into starting this, if I say 1/2 and 2/4, and I ask you, are these two fractions equal? Well, looking at these, you should know that both of these are equal. So when we have two fractions that are equal, there's something that we can actually do. And what that's called is we can cross multiply. We multiply what's called our means and our extremes. So when we cross multiply one numerator with the opposite denominator, 1 times 4, and then the other denominator with the other numerator, 2 times 2, it still is equal. 1 times 4 is equal to 2 times 4, or 2 times 2, which is 4. So you see, when we have two fractions that we know are equal to each other, we can cross multiply, and it still gives us a true and equal statement. So if I want to solve for this, I can do what's called cross multiplying. I'll multiply one numerator with the opposite denominator, so x times 20. And since they're equal to begin with, I know that these cross products are also going to be equal, of 4 times 15. Well, 20 times x, we can write it as 20x, and 4 times 15 is going to give me 60. And then from there, all I have is a one-step basic equation. So what is the inverse of multiplication? Well, that is division. So I divide each side by 20, and x has to be equal to 3. And we can plug this back in to see, does this actually work? Does 15 over 20 reduce to 3 over 4? And it does. Right? So when we are solving through proportions where two fractions are equal to each other, then we need to cross multiply because those products will always be equal as well. All right, so we're going to do one more question. It's a little bit harder than this, and that'll be it for this video. All right, so now this problem is 9 over k minus 7 is equal to 6 over k. All right, this one is a pretty challenging question, especially at this grade level. But since we can't use some of these other methods that you might have been able to use for question number 3 if you did it a different way than me, we do have to use cross multiply for this. So we will cross multiply and get 9 times k. And we know it's going to be equal to the product of the other cross multiplication. So now we can do 6 times k minus 7. Now let's simplify each side of our equation first. So 9k will just be written as 9k. And we're going to distribute the 6 in and get 6k minus 42. Now I look and see, oh, well, I have variables on both sides of the equation. So now I need to go ahead and move all of my variables to one side. So to do that, I will subtract 6k from both sides. And 9k minus 6k is going to give me 3k now. And now 3k is equal to negative 42. Well, our last step, now that we have all of our variables on one side, we look and see, well, oh, we actually just have a very basic one-step equation. And it's 3 times k, so to get rid of times, we will then divide. And that means k is going to be equal to negative 14. All right, and we can plug it back in and see, does that actually work? Well, 9 over negative 14 minus 7, does this equal to 6 over negative 14? Well, negative 14 minus 7 is negative 21, so it'll be negative 21. And this will be negative 6 over negative 14, or 6 over negative 14. 3 can divide evenly into both of these, so this will then give me 3 over, so negative 3 over 7. And does this equal to? Well, 2 divides evenly into both of these, and positive divided by negative is negative. and 6 divided by 2 is 3, and 14 divided by 2 is 7. So yes, it does give us two equal fractions. All right, that is it for this video.